guys, this is Ms. Clark. I'm going to go over this stuff real quick just to remind you that Friday is Amnesty Day. So you can work on whatever you're missing. I'm going to send your weekly Geometry Weekly updates on Thursday. That way you'll know what you need to work on Friday. Remember, do your Unit 3 and Unit 2 performance tests. I'll make sure I put that on your weekly report so you'll know which ones you need to work on so you can get the best grade. Here is our proof. We're going to complete the proof that triangle GIJ is similar to triangle HKJ. So we started this stuff on lesson 403. So if you watch the help recording, this should look familiar. Hopefully you'll go back and watch it if you haven't. So the first one, it says that line GI is parallel to HK. We can see that from the picture, those two arrows, so that is a given. And then it says that angle HJK is congruent to GJI. Those angles that make an X, so that is vertical angle theorem. That's how we know those are congruent. And then it says that angle I is congruent to angle K. They are inside the parallel line, so it's an interior pair, and they're on opposite sides of the transversal, which is that IK. That's the transversal right here. So that is alternate interior angles are congruent, that theorem. So now we see that two of these angles are congruent to each other. So that means that these triangles are similar because of angle. All right, we had a triangle MNP that will be dilated according to the rule D sub M3. So that means the center of dilation. I'm going to change my color here so you can see good. Let's do red. So this tells you the center of dilation. So this is not the origin, it is M, okay? And we're dilating it 3. So we're going to find the new coordinate for N. So we need to know how far M is from N to start off with before we can multiply it by 2. So M's coordinate is -1, -2, and N's coordinate is 0, 2. And we can do the distance formula, which is the square root of . So hang on, I'm just going to paste the distance formula. That'll make it easier on us. So that's our distance formula. So we just need to label these. So we'll say this one is x1, y1, and this one's x2, y2. And then we fill them into the formula. So the square root of x2 is 0 minus x1, which is -1, squared plus y2, which is 2, minus y1, which is -2 squared. So do it in the parentheses first. Change it to addition. Change the sign of the second number. So this is 1 squared plus. Change it to addition. Change the sign of the second number. So this is 4 squared. 1 squared is 1. And 4 squared is 16. So this is the square root of 17. So I see why they didn't give you this one in the actual thing. So that just means we have to multiply this by 2. We can kind of see that it is 1, 2, 3, 4 from there, and it slopes inside here. So we can kind of guide ourselves so that we have to triple that. Oh, we're not going to be able to go far enough. So let's double this. Make it easier. we're just going to double it. So it would go 1, 2, 3, 4 more, but from here to here. So the new coordinate would be 1. That's gone by. No, that's 3, 4, 1, 6. So it's usually not going to be a square root like that. I just didn't want to give you an actual quiz answer, but I did want to go over it. Also, you can do a screenshot with your Chromebook. To do the whole screen, everything on your screen, it's Control Switch Window. And if you look closer at this, it looks like this. That's what this top one looks like. It's like 3 little squares. And it will save to your downloads, and you can get it from there. Or if you want to do partial, you do Control and hold down Shift and that same switch window key. So then it's going to give you a cursor where you can choose what you want to take a picture of, and then it's going to also be saved in that downloads folder. So we're going to do 404. And we're going to talk about how the proportional sides factor into finding triangles are similar. It means the sides have to be proportional to each other. Notice how the top of these fractions are all this triangle and the bottom is all this one. That's how you have to keep it lined up. So you have the correct proportions. So just keep that in mind. And then the sides here to here are corresponding. So you see that AB corresponds with DE in the name. That's why they're in the same proportion. We'll keep talking about that. So we have side, side, side similarity theorem, where you set up all 3 of those proportions and they're all equal to each other. That means this triangle is similar. All 3 sides are proportional. Or if you just find 2 sides in the included angle, meaning that angle has to touch both the sides you're talking about, included angle, you can do it that way. But this just means similarity, when we talk about sides, they're not congruent, they're proportional. We'll do this in class. And I'll make another recording for this. So that's just beginning. Then I'll give you another